All right, good morning, everybody. Welcome to the Unit 5 quiz review. So let me flip my computer around. It's a little bit easier for me to write on. All right, so we're going to go through the questions one by one, just like we always do. And if you have any remaining questions, just see me in class. All right, so number one, pick the statistical questions from the list below. All right, so this is a multiple select question. Of course, questions tomorrow will be different, but here's what to look for. You're looking for anything that will have a varied response from person to person. So if I ask two people, they might say something different, right? That's what we're kind of looking for a statistical question. So what are the number of pets students have? That is a statistical question because I might ask one person, they might say 3 pets, and someone else might have 2 pets, right? So that's one of them. Who has won the most World Cups? That is not a statistical question because it is a factual question. I don't know the answer to that, but whatever the answer is, isn't gonna change. We're not gonna guess, obviously. Whatever the true answer is, the true answer is. And if people know it, they'll all say the same thing. How long does it take students to travel to school? So that's a statistical question because, of course, some people might take 10 minutes, some people might take 15, etc. How many presidents of the United States have there been? That is not a statistical question, right? Because of course, that is a single answer, right? 46 presidents is the answer. And if you know that, everybody would say 46. So what is your favorite subject? That is a statistical question because again, I might ask somebody, they might say math. I might ask somebody else, they say history. They're wrong, of course, because math is their favorite, but still, it might change person to person. What are the colors of the American flag? That is not a statistical question because of just red, white, and blue. And everybody would say the same answer, right? That is a factual question. All right, so just A, C, and E were the statistical ones there. So again, you're looking for questions that when you ask somebody or multiple people, they would give you different varied responses. You're not looking for questions that are factual questions like the American flag or how many presidents or who won the most World Cups. Number two, select the data sets that represent populations. Select the ones that represent samples. Okay, so this is really two separate questions on the test. But because they kind of have an overlap, I decided to make them one question on the review here just so that we can just talk about them. But I believe they are two separate questions on the test. So in one question, you'll look for just the populations, and one you'll look for just the samples. But here I want to show you both at the same time. So A, all the students at CCHS were asked to respond to a survey about their opinion on longer school days. So we're asking all the students at CCHS for all the students at CCHS, right? It's about them, and we ask all of them. This is population, right? Because we're trying to figure out the population's response here. Okay, I should really do a little bit better job trying to write this. All right. So Mr. Morley asks all of his students about how many siblings they have in order to find out the average number of siblings among families in Pasco County. So I am asking all of my students, right? Mr. Morley is asking all of his students. However, it's not for all of his students. It's not defined how many siblings all of my students have. It's defined the average number of siblings for all of Pasco County. So you see how we're expanding that, right? I'm asking all of my students, but only as a subset of all of Pasco County, right? I'm not asking all of Pasco County. I'm asking just my students to make a discovery for all of Pasco County, which makes my question to my students a sample, right? So this one is a sample. Again, it's because I am focused on one group to find information for a larger group. That's what makes that a sample. So look at C. Mr. Morley asks all of his fifth period students who their favorite teacher is to determine the most popular teacher of his fifth period students. So again, I'm asking all of my fifth period students, and I only care about their opinion. I'm not trying to ask the fifth period to know about all of my students, or I'm asking all of fifth period to know about all of Pasco. I'm asking all of fifth period for the sake of all of fifth period. So That's a population, right? I'm asking everybody in the population here. And then lastly, census workers collect data from random households in Florida to find out what proportion of homes in Florida have pets. So asking random households in Florida to find the proportion of homes. It could be a little more specific, but the idea here is you're asking um, some households, if they have pets, to find out if all households in Florida or what the amount of houses in Florida have pets. So we're asking some houses in Florida to know about all of the houses in Florida. So again, think about that. You're asking a handful of houses to learn information about all the houses, which makes that a sample. All right, so ultimately a population is asking an entire group of people for that entire group of people, right? Or whatever. A sample is asking some people in order to find out information for a larger group of people. So that's what you're kind of looking for, looking at who you're asking and who you're asking for. Okay, that's the thing. Number three, which of the following are observational studies? Which ones are experiments? So again, I think this one might be a two-part, two separate questions as well. I don't remember, but we'll go through them and identify them. Recording the number of students walking around the courtyard wearing Crocs. This one is an observational study. Observational studies are ones where we don't really intervene. We don't really regulate it. We don't control it. We just sort of gather data and make conclusions, but we don't do anything to kind of initiate or add treatments to anything or separate people into groups. None of that. Observational studies are strictly just gather data, observe, and analyze your results. So B, counting the number of babies that cry while at daycare center. That, of course, again, is an observational study. We're not imposing any treatments here, right? We're not saying, hey, babies, some go here, some babies go there, and we see who cries. No, we're just observing it. Separating ninth graders into two groups. One group drinks sugary drinks, the other drinks only water. So because we're regulating it, right, we are separating them into two groups. That's what makes this one an experiment. And then create three groups where one group gets trial medicine type A, one group gets type B, and one group gets placebo. So again, we're creating groups. Anytime we create groups, we're creating treatment groups, right? And we assign different treatments here. In this case, you can see type A, type B, and a placebo. This, of course, is another experiment. All right. What is convenience sampling, and give an example? So convenience sampling is, asking the most a convenient group of people, like the first people you talk to, essentially. So, I don't really know if I have a definition for it here, but I'll sort of the quiz doesn't ask you for a definition. Oh, by the way, I'm just wanting to let you know that. It doesn't ask for the definition, but you do want to understand it, right? The quiz is going to give you multiple choice examples, and of those examples, you have to figure out which one's convenient. So that's why we're going to define it and give an example so that we have a better idea of which one to pick for tomorrow. So convenience sampling. Let's see here. Convenience sampling is it's kind of in the name, right? It's sampling the easiest, maybe not the easiest, but an easy group of people, right? Kind of the first people you can find. It could also be like just asking friends, right? Just something convenient. To give an example, Mr. Morley asks the first 10 students who walk in the room. Kind of out of room there, but yeah. I'll be whatever my survey question is, the first 10 people that come in, I ask them, boom, 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 right? Whatever that survey question is. So that's convenient sampling. So number 5, what is voluntary response sampling? So voluntary response sampling. Oop, my hand slipped a little bit there. Voluntary response sampling is when subjects, right? Subjects can choose whether or not to participate. So an example of this is Mr. Morley shares an online poll with his students, right? So when I do that, if I share an online poll with my students, then some of them will click it and respond, and some of them will ignore it. And so, they're voluntarily participating or not participating. So online polls typically are voluntary. Bias creates which of the following? Bias will create overestimating or underestimating. Bias doesn't create exact values. Bias is going to lead you to be inaccurate. And to be inaccurate, you would be overestimating or underestimating. So this is a multiple select question. It is not all options. It is A and B in this case, okay? Because exact values does not count. All right, moving on to number 7. Define each type of bias. Let me get that set up. So undercoverage is where some members of the population are less likely to be chosen or cannot be chosen. There we go. B, non-response. An individual, I don't know if I spelled individual. Here you go. Selected for a study cannot be contacted or refuses to participate. So here you go. Yeah, non-response. People can't be contacted or they refuse to participate. They are not responding to your survey. Now let's talk about response bias. Ooh. There is a consistent pattern of inaccurate responses. Sometimes individuals feel compelled to answer a certain way. So like I said it before in class, but like if I ask, hey, what's your opinion on the new traffic light going up on Old Pasco Road that's going to back traffic up for 20 minutes longer each day? I'm making it sound so terrible that of course I'm gonna lead you to say that it's a bad idea. So that's response bias. That's one example, right? Another one, people are lying to you. So you might ask them a question. They might not be truthful. They might lie to you. That is also response bias. All right, so moving on to number 8, true or false? Implementing a method to select a sample purely randomly will eliminate all chances for bias. This is false. Bias can't necessarily be entirely eradicated. We could do our best to squish bias, to limit bias, to try and, make it um, have as small of an impact as possible, but we can hardly ever get rid of it. So that's why that one's false. What are ways to select a simple random sample? So a couple ways, of course, would be, um, oof, uh, obviously slips of paper, right? Slips of paper. Two main ones are slips of paper, random number generator. Popsicle sticks could be one, right? Where if you put everybody's name on popsicle sticks in a little cup and you pull them out. I always liked my wheel, right? Wheel with equal slices, right? Those are just to name a few. What happens as we increase the sample size? So we've seen this one recently. So when we increase the sample size, that's going to give us more confidence that we have a more accurate answer. And that's because the sampling variability is reduced. The odds of your sample being further from the truth is gone down, right? So you're more likely to get answers closer to the truth, which means your variability is reduced, which is good, and your confidence is boosted, which is good. So it's definitely those two. What happens as we increase? Oh, I think I meant to say one of these is supposed to say decrease. So we're gonna make this one decrease. I don't know how I missed that. I'm gonna have to check the quiz now to make sure that's correct. If we decrease the sample size, the opposite thing occurs. Our confidence goes down because the variability has gone up. Variability goes up means that you might get a wider range of answers. And if you have a wider range of answers, then you're not as confident in the possible results. So, okay, I'll have to check the quiz, make sure there's no typo there. And then finally, an SRS of 20 students is selected. Each provides their height in inches. The sample mean is found to be 68 inches. What are all the options for the sample mean height if we select another simple random sample of 10 students from the same population? So basically we're saying, hey, we have a sample and that sample average was 68. So if we go out and we get another sample, what's possible? Is it possible that my sample would be larger than 68? Yeah, that's possible. Is it possible my sample could be less than 68? Sure. Is it possible that I'll do another sample and it will be 68 again? Yes, of course. So yeah, and the whole idea here is because of sampling variability. Sampling, when you sample and you take the average, every sample is different. Every sample is unique. So every sample will give a slightly different result. Granted, they shouldn't be too far apart from each other. They should be very similar results, but they will be different results. So some will be a little higher, some will be a little lower, and that's sampling variability. So it's possible you can do any of the three here. I think that's going to be it. So if you guys have any other questions, let me know. I'm going to post this and yeah, best of luck on the quiz. I will see you guys next time. Bye for now.